Hey guys, it's time to talk about XBee and API mode and transmitting. I got a really quick lesson for you today. We're just going to do a quick hello world. We're just going to do a really basic transmission using the XBee radios in API mode. We're going to do this with the XBee's connected to XCTU, as you see that you'll see on the screen. We're going to do it with an XBee radio attached to an Arduino, and we're also going to connect one of these XBee radios to a custom PCB that I've got here that we built. So let's go ahead and get started. Alright, so up on the screen we have XCTU, and the first thing we're going to need to do is get our radios configured here, right? So let's go ahead and get these connected. Discover radio modules. My radios are already plugged in, COM 4, 7, and 8. Click next, click finished, and just expand this so you can see these. Those are the three that I have connected to my computer right now. Add those devices, great. And what we're going to do is go to the configuration screen, and we're going to run through these configurations real quick. I'm not going to go into too much detail. We've done configuration before in the past, but I'll just show you the high points. There we go. All right, so great. So for this, we're going to use before I get started here, I want to pull up the guide. So I am using this guide right here. Learned a lot from it. The configuration that we're using sort of is on page 64. We're going to use this configuration right here. I've got it over here on my left in a text box just to make it a little bit easier to follow. So for the coordinator, our device role is going to be forming the network, of course. PAN ID is 2015. JV coordinator verification is disabled. NI. Now here's a key difference between the configuration here in the guide and what I'm using. I'm going to go ahead and just keep using my identifiers, coordinator, router, and end device from some of the previous lessons that I've done, just because it doesn't matter. And to be honest with you, I got a little bit confused between sender and receiver. You know, those names just don't mean anything, because in API mode, any radio can send to any other radio as long as it has the other radio's address. So drop that down there. So NI for this one is going to be coordinator, and then API mode without escapes. Come on down here. Yep, API mode without escapes. And then finally, just to show you sleep, all of them are going to be set to no sleep. They're all going to be set as routers, even the one that says end device. And that's really just to make this more simple. This is a really simple transmission. We're not worrying about sleep or encryption or anything else right now. The router and the end device are set up just exactly the same as each other. The device roles are both going to be join network, as we see right here, which is CE of 0. PAN ID 2015. JV, of course, we're going to enable that to make sure that there's a coordinator before they join the network. And they both have API mode without escapes, and they're both sleeping. So there we go, API mode without escapes, and they're both not sleeping, I should say. All right, cool. So we've got those configured properly. Now the next thing we need to do is confirm all the radios are on the same network. So one way we're going to do that is just click Discover on the network. There we go. There's the coordinator. There's the end device. So these both show up. I can click Add Selected Devices and turn them into remote modules, but we don't need to, not for this demonstration. Cool. So they're on the same network. Everything's going to work. Next, we're going to go use the XCTU frame generator to create some frames. Alright, so let's get over here in our console working mode, and what I'm going to do here is I'm just going to detach all three of these, and I'm going to pause the video for just a second while I get the workspace set up. Okay, so I just like to get the workspace set up with each of these console windows quite a bit longer, because when you're working with the API frames, there's a lot of details that are going to show up here. So we're going to open up each of these, I guess they're called ports, the serial connections, and we're going to start with creating a frame. So when you're using API mode, it's a lot different than transparent mode. So in transparent mode, we used to be able to click. I'm trying to click in there and then just type something. You can't do that in API mode. In API mode, we have to create frames. Now, I'm not going to go into a whole lot about frames right now, because it just that's going to be another lesson down the road. So what I'm going to do here is I'm just going to create one called Hello Coordinator, right? And so what we can use, we're going to use this frame generator tool. So you click that button. I'm going to make this a little bit bigger so we can see it. And there's lots of different types of frames. We can go over some of those later. The one that we're concerned about today is transmit. This is the basic communication that we're going to want from our end devices talking back to our coordinators eventually, right? So we click transmit request, and so we have a lot of these parameters and settings here. The ones that are in gray are default. You can't change those. You can change the frame ID. We're not going to do that. If you recall, we're writing this for the router, and it's going to be talking to the coordinator. So we have the coordinator has a 64-bit destination address. That happens to be this number right up here, 0013A. So 0013A 2004.197C687. There we go. Oh, I must have missed something. I'll just do it again. 0013 A2004.197C687. There we go. So you notice how it turns red if you don't have everything in there. So that's actually kind of a neat thing. We're not going to mess with this 16-bit destination address. Just to let you know, FFFE is the code for an unknown address. So we know it's 64-bit address, but we don't necessarily know it's 16-bit address. I don't know it, at least right now. We're going to leave broadcast radius and options set at 0, and then we're just going to type our message in here. So hello coordinator from router, just like that. And then when we're done, and that's it. That's all we have to do. Now we click OK. We click Add Frame, and now we have a frame down here. Now, you notice nothing was sent. What we have to do now is send this selected frame. So we'll highlight the frame that we want to send. We'll click that button, and now you'll see that we have a transmit request from the router, and then we have a status. So if we click the transmit request, you'll see why I wanted these to be nice and long. What was sent was all of these bytes. This was all the byte code that was sent to the coordinator, right? And all of this information makes up the frame. So what I'm going to do is I'll pull this up, this frame generator tool, and we'll just so you can kind of see what's going on here. So if we look through this transmission request, you can see 7E00 2 delta 10 0 1. Then there's a 64-bit address, which is all of this to 87. Then we have our 16-bit address right there, broadcast radius, options, and then here, this 48 all the way down to 2E. This is all of the this is the hex code for the hello coordinator from router, and we can know that because we can click hex, and this is the hexadecimal version of this ASCII that we put in. So that's pretty cool. And then finally, the checksum is CE. I'm not getting into checksums right now, but the checksum is there. So all of this data, or all of this was sent in order for us to send hello coordinator from router. This is how it all breaks down here. You can see as soon as we click transmission request, we immediately got the status message back, and this is one of the cool things about API mode is you get these read receipts, if you will. And what we're really concerned with right here is the delivery status success. Great, that means it was sent. Well, we know it was successful because over here on the coordinator, we now have the packet that was received. And here's all the information that was received, and here's how it was interpreted, and there is our data. So one thing that's another great thing about API mode is this 64-bit source address. This actually tells us inside the packet from which radio it was sent. So this is a great part about the protocol. There's no need to pack into the data the RF data like this hello to coordinator. You don't have to create your own protocol there, so you know exactly from where it was sent. That's neat. Now you notice we just sent it from the router to the coordinator, but we can send information from the coordinator back to the router. Let's do that real quick. So hello router. Create the frame. We're going to make it a transmit request. Let me open this up a little bit. Now we're going to go to the router, which is 0013A20041983 Delta Alpha 8. Great. There we go. Great. And so we just added that frame. We click add it here, and then I can select it and send the frame. And there it was. There's our request right there. Our status message said it was successful. And if we come over to the router's serial console, we can see the packet that was received from the coordinator. I mean, totally cool. All right, and we can do this between all of these. As long as you know the 64-bit address, you can send to any, you can send from any device to any device. So there's a neat little tool that we can use here, a little shortcut if you wanted. So remember how I said that the packet was just this hex code. So what I'm going to do is I'm just going to copy all of this code right here, and I'm going to go over here to the end device, and I'm going to create another frame, but instead of going into the frame generator immediately, I'm just going to pop this in. I'm going to add that frame and then send it. And there we go, transmit request. I just sent hello coordinator from router. Now really I sent it from the end device, but that's just the data I had in there. I got a status back, successful. So where did we send that again? So we sent it to this address, C687. We sent it over here to the coordinator. We can see the packet that was received, and our data down here says hello coordinator from router, right? So once again, really cool thing about API mode, that's not actually where we got it. We received it from this source address that ends 29FD. 29FD is the end device. So this is a really good receipt. You can send backwards and forwards. You can copy it. Now, that's pretty cool. I really like this. And you can do this with any sorts of frames. If you want to play around with it, you can go into the frame generator tool, and when you're in XCTU like this, you just pick the various commands that you have, and this is where you play. Alright, so what's next on here? That's copying, that's sending and receiving between radios, copying frames. Oh yeah, here's a good one. So right here on the router, we'll just use this frame generator to help us out. What I'm going to do is I'm going to make a transmit request. Now, see, what if I don't know explicitly the 64-bit address, I can use the default, which is for the coordinator. So in the 64-bit address of just all zeros, that is reserved for the coordinator. So if I just say hello world like this, and then click OK, add frame. When I transmit this, boop. Oh, it's funny. I was in the coordinator when I did that. So what happened was I transmitted it to this default address, right? I immediately received a packet saying hello world from this address, which happens to be myself, or itself, and then the status was, look at this, self-addressed. So wasn't even intending to show you that, but that's pretty cool. Now what's really neat, once again, I can take this hex code right there, and I'm not going to change anything at all. I'm going to go to the end device and then send it from the end device. And so the end device just sent it to the default coordinator address, hello world, and then the coordinator received hello world from 29FD, which is the end device. So that's pretty neat. All right. So that's the real basics, how to transmit receive using XCTU, and I'm going to pause right now and get set up for the next thing. All right, so I'm back again, and now it's time to get into some really fun stuff. I like this part. This is where things really start coming together. So the next thing we want to do is, or the next thing I really wanted to do was to learn how to have the radios talk to each other, but being powered by an Arduino. But I wanted to use API mode, not transparent mode, like we saw in one of the previous videos, right? So let me switch this over here to desk cam. There we go. And you'll see right here we have, that's the coordinator that we were using before. Here's the endpoint, right? And what I've done is I've wired the endpoint up to the Arduino just exactly the same way I did in our transparent mode video. But just to refresh, I have the Arduino hooked into the, I didn't state this last time, but the Arduino, or I'm sorry, the XBee is hooked into the 3.3 volt on the Arduino. You got to keep in mind that the XBee runs on the 3 volt. If you put the 5 volt on there, or if you plug it into the 5 volt, it'll work for a while, but it will break eventually. So have the 3.3 volt and the ground. I have the output from the digital out going to pin, let me check here, output there goes to the receive to pin 12, and the digital input is hooked to Arduino pin 13, right? So that's the basic wiring, really simple wiring. And this is a sketch, really simple. Hello world, sending hello world via API, via the XBee API mode through an Arduino. All right, cool. So it's really, there's a lot of stuff here, but it's really just this right here. First thing we do is I created this thing called this byte packet, or a byte. What this is the hex code that looks just like we had over here, right? If you recall, I think this is the hello world one we just did. There we go. Yeah, there's the hello world code, right? So all I did there was copy this frame. I created the hex code over here, copy the frame, and I want it to default to go to the coordinator, right? Click OK, and let me just go ahead and put it in here while we're at it. There it is. And what you have to do, and this is the trick, is you create this this array called packet, or called anything. It's a byte array, and then you take each of these 7E00 and you turn it into that byte format. The way you do it is you put the 0x in front of it. That's how. So 0x7e comma, and I just went in there and just typed each of those in. This is not the way you want to do it in a production environment, of course. This is just to show how it works. In a later video, we're going to talk about how to do this and create these packets programmatically. All right, so that's the byte packet that has hello world in it. Then down here in my setup, I open up the regular serial, which is going to be good for the Arduino. We'll be able to see this. In fact, let me just open up the serial monitor. Oh, won't be able to do that till I actually connect it. So we'll open up the serial monitor and we'll see what's going on there. What this note says is when you hook this up to just a standard PCB, like a custom one, you don't need all this hardware serial because we're just using the software serial. So you open up the serial port, give it a second to spin up, and I just wanted to put out a quick little confirmation message that we booted up to the hardware serial port, and then the loop is right here, right? This is it. So we're using the software serial, and we're writing, and this is how you write the bytes, we're writing the packet. and we're using the size of packet, and that's just the nomenclature for write. You need to send it the byte array and then tell it how big it is. Now you can type this in explicitly, just like this right here, serial.write packet of 30. That's how many bytes there are in here. You count on them. But using size of packet's the best way to go. All right, so what I'm going to do here, I'm going to plug in our, I gotta go this way. I'm going to plug in the Arduino. Right, let's get that over there so you can see everything. And we're plugged in. I'm going to go ahead and load up this sketch. Tools, we'll look at the serial monitor. Did I set it up properly? Oh, we're on. Compiling sketch. Uploading. There we go. There's a little flashing light. Great. It's done uploading. All right. Setup's complete. It says check receiving radio console. So what we're going to do over here is we'll go to the receiving radio because we're sending this to the coordinator by default, and we'll open up this serial port. And there it is. There's our packet. Hello world. And it was sent from 9829FD, which was, if you recall, that's the address of the end device. Now, the other thing we can do is we can just use this discover tool. Yeah, there it is. There's our end device. We can add that. And now this is actually a remote module. So if we wanted to do any sort of configuration on it, we could do that. Let me open this up real quick just so you can see there it is. Yeah, so there's the MAC address, which is the SL and SH, so the serial or the SLSH parameter. But there it is. Yep. All right. So this little bitty bit of code is all you need to begin transmitting from an Arduino through an XBee radio to a coordinator that's attached to something else like your PC, and you'll begin receiving that information. Got this error down here. It doesn't seem to matter. Everything seems to be running okay. So let me just double check one more time that it'll go in. There it is. It's just being a little bit slow. Yeah, it's probably because I'm recording and I have these video cameras going. So that's probably it. But everything's working. All right, great. So I'm going to go ahead and pause the video, and we're going to set up for the last little bit of the lesson. Okay, so now I'm going to introduce another bundle of mess in here. This little guy is a project that you may have seen in some other videos. It's a project I've been working on for a little bit of time, and effectively this is using just an 18 mega 328 processor on it. Yeah, there's no company name on there, so that's good. So it's using an 18 mega processor that you can program using a just using a programmer like one of these right here. I can put up a video about how to do that some other time. But what I've done is I've taken this API TX Hello World sketch, just as you see it right here, and I've loaded it onto this. So as soon as I turn the battery on or hook the battery up, we can start seeing the packets come in. So I just opened up the serial monitor, and we can see the packets coming in from 29FD, right? So this is our end device, that just like we had it when we left off before. There it is. There's our end device. We'll go ahead and select that. Great. So we are receiving packets from the end device. Let's go ahead and connect that I haven't got any of the LEDs working in this sketch, so what we'll do is we'll close up those frames and let's just see what starts coming in. So here's a packet from 4F0E. Well, we don't know that one. That's this guy right here. And to show you, what we'll do is we'll just discover everything on the network now, and now we'll have, you know, 2 remote radios. Yep, that's the one. It's called sensor. All right, and there's our end device. So now both of these, both this one that was the end device and this one that we call sensor, are communicating directly with the coordinator. Yep. And what's really great about this is you can have, you know, dozens and dozens of these radios coming into one coordinator. These are all coming in at these are coming in at 5-second intervals. But because we have the read receipt, we can see what's going on. There we go, just like that. All right, so guys, that's it. So I'll go ahead, if you want this this sketch right here, I'll go ahead and send it out to you. Just let me know, and that's it. That's how you can transmit data from a Arduino custom PCB with the XBEE3 chip antenna to another coordinator out there. All right, so next time when we get together, we're going to talk about what is it? Yeah, the next part we're going to do is the XBEE.h library, right? And that's going to be a really important thing to do. The XBEE.h library makes creating frames a lot easier. You can do it programmatically, and that way you can change things on the fly. You can change your your messages, and so when you're sending data, that data is going to change, and so your checksum is going to change. So the XBEE.h library really helps out with that. And the place to find that, actually, if you go to your user guide, you can go to page 69 right there, and it talks about libraries, and it's this Arduino library right here. Will take a second to open up, I'm sure. Oh, come on. Well, you can go to it. Anyway, we'll talk more about that next time. So, and oh, here it comes. Here it comes. We'll take a look. We're not going to go into it. We'll just take a look. Now, one thing you'll notice when you start looking at this XBEE.h is that it keeps referencing Series 1 and Series 2 in the examples, and that got a little bit tiring for me because there wasn't a Series 3. So far, for the really basic stuff, I haven't seen really a difference between working with the Series 2 and Series 3, but I think as we go a little bit deeper, we might find some of those. So anyway, well, thanks a lot, guys. It's been really good fun, and I guess I will see you next time.